Hi everyone, myself Prajul. Today we are going to discuss about multi-tier architecture of data warehouse. Multi-tier architecture of data warehouse. The contents we are going to discuss in this video are: what is data warehouse, multi-tier architecture of data warehouse, advantages of multi-tier architecture. What is data warehouse? A data warehouse is a repository of information collected from multiple sources, stored under a unified schema, and which usually resides at a single site. Data warehouses are constructed via a process of data cleansing, data transformation, data integration, data loading, and periodic data refreshing. Data warehousing provides architectures and tools for business executives to systematically organize, understand, and use their data to make strategic decisions. Multi-tier architecture of data warehouse. Data warehouse often adopts a three-tier architecture such as bottom tier, middle tier, and top tier. Bottom tier data warehouse server. The bottom tier consists of monitoring, administration, data warehouse, data marts. The middle tier OLAP server consists of OLAP servers. Top tier fronts and tools, queries/reports, analysis, and data mining. Bottom tier. The bottom tier is a warehouse database server that is almost always a relational database system. Backend tools and utilities are used to feed data into the bottom tier from operational databases or other external sources, such as customer profile information provided by external consultants. These tools and utilities perform data extraction, cleaning, and transformation, as well as load and refresh functions to update the data warehouse. The data are extracted using application program interface known as gateways. A gateway is supported by the underlying DBMS and allows client programs to generate SQL code to be executed at a server. Example of gateway includes ODBC and OLEDBC. A bottom tier that consists of a data warehouse server, which is almost always a RDBMS. It may include several specialized data marts and a metadata repository. Data from operational databases and external sources, profile data provided by externals are extracted using application program interfaces called a gateway. A gateway is provided by the underlying DBMS and allows customer programs to generate SQL code to be executed at a server. Examples of a gateway contain ODBC and OLEDB, Open Database Connection, and Open Linking and Embedded for Database by Microsoft, and JDBC, Java Database Connection. Middle tier. A middle tier is an OLAP server that is typically implemented using either a relational OLAP model, that is an extended relational DBMS that maps operations on multidimensional data to standard relational operations, or a multidimensional OLAP model that is a special purpose server that directly implements multidimensional data and operations. ROLAP. These are intermediate server which stand in between a relational backend server and user front-end tools. They use a relational or extended relational DBMS to save and handle warehouse data, and OLAP middleware to provide missing pieces. ROLAP servers contain optimization for each DBMS backend, implementation of aggregation, navigation logic, and additional tools and services. ROLAP technology tends to have higher scalability than MOLAP technology. ROLAP systems work primarily from the data that resides in a relational database, where the database and the dimension tables are stored as relational tables. This model permits the multidimensional analysis of data. This technique relies on manipulating the data stored in the relational database to give the presence of traditional OLAP slicing and dicing functionalities. In essence, each method of slicing and dicing is equivalent to adding a where clause in the SQL statement. MOLAP. A MOLAP system is based on a native logical model that directly supports multidimensional data and operations. That data are stored physically into multidimensional arrays, and positional techniques are used to access them. One of the significant distincts of MOLAP against ROLAP is that data are summarized and are stored in an optimized format in a multidimensional cube instead of in a relational database. In MOLAP model, data are structured into proportional formats by clients reporting requirements with the calculations pre-generated of the cubes. Top tier. A top tier that contains front-end tools for displaying results provided by the OLAP, as well as additional tools for our data mining of the OLAP generated data. The metadata repository stores information that defines DW objects. It includes the following parameters and information for the middle and the top tier applications: a description of the data warehouse structure, including the data warehouse schema, dimensions, hierarchies, data mart locations, and contents, etc. Operational data, metadata, which usually describes the currency level of the stored data, that is active, achieved, or purged, and warehouse monitoring information, that is usage statistics, error reporting, audit, etc. System performance data, which includes indices used to improve data access and retrieval performances. Information about the mapping from operational database, which provides resource RDBMS and their contents, cleaning and transformation rules, etc. Summarization algorithms, predefined queries, reports business data, which include business definitions, ownership information, etc. Advantages of multi-tier architecture: scalability, better performance, modularity, security, improved resource management, easy maintenance, improved reliability. Scalability. Various components can be added, deleted, or updated in accordance with the data warehouses, shifting needs and specifications. Better performance. The several layers enable parallel and efficient processing, which enhance performance and reaction times. Modularity. The architecture supports modular design, which facilitates the creation, testing, and deployment of separate components. Security. The data warehouse overall security can be improved by applying various security measures to various layers. Improved resource management. Different tiers can be tuned to use the proper hardware resources, cutting expense overall and increasing effectiveness. Easier maintenance. Maintenance is simpler because individual components can be updated or maintained without affecting the data warehouse as a whole. Improved reliability. Using many tiers can offer redundancy and failover capabilities, enhance the data warehouse overall reliability. Thank you.